Well, partial derivatives of a function of 3 or more variables even, although we won't do the or more right away, that's also possible, remembering that we hold the other variables as constants. So if we have a function w equals f of x, y, and z, then the partial derivatives of w are defined in the same way. And so you could say df dx equals f sub x of x, y, and z, or w sub x, which means the partial derivative of w with respect to x, or dw dx. Again, the funny looking d, it's the Greek letter delta, for partial derivative, and they're defined just as you would expect. Here's an example. If resistors of resistance R1, R2, and R3 are connected in parallel like this is to make an R ohm resistor, in other words from here to here the resistance is R, the value of R can be determined by the equation 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. That's a kind of a common and famous formula from electronics. It might be called Ohm's law, but I'm not sure. So find the value of the partial derivative given when R1 equals 30, R2 equals 45, and R3 equals 90 ohms. So this is a measure of how fast the resistance of the circuit is changing for these conditions when we adjust R2, because that's the derivative we're looking for, the partial of R with respect to R2. So to find this, we differentiate both sides of this resistance equation with respect to R2, and then solve for the expression, this expression right here above the box, partial of R divided by partial of R2. And so if we differentiate this expression with respect to R2, of course the derivative of 1 over R is negative 1 over R squared, so that's pretty easy to understand, times the derivative of the inside function, which is R, and that's actually what we're trying to find. And that equals partial of this expression with respect to R2. Well, with respect to R2, R1's a constant, so this is a constant, and the derivative of that constant is 0. The derivative of 1 over R2, of course, is the derivative with respect to R2 of 1 over R2 is, it's like saying what's the derivative of, with respect to x, of 1 over x? So what's negative 1 over x squared? So here it is, negative 1 over R2 squared. The derivative of R3, remember, 1 over R3 rather, I should say, but R3 is a constant, so 1 over R3 is also a constant, and the derivative of a constant is 0. And so we just need to solve this expression for this particular variable here, partial of R with respect to R2, and we multiply both sides by negative R squared, and we get the fact that that partial derivative of R with respect to R2 is R over R2 squared. Now the question is, how do you find R? Well, we were given some information. R1 was 30, R2 is 45, and R3 is 90, and we're given this nice formula. So to find R, so we can substitute something into this, we'd say 1 over R equals 1 over 30 plus 1 over 45 plus 1 over 90. And with a common denominator of 90, that's 3 plus 2 plus 1, so 6 over 90. 1 over R is 6 over 90. And so inverting both sides, R equals 90 over 6, which is 15. So we have something to put in here. And R2, if you recall, was given at 45. I'll refresh your memory back there. R2 was given to be 45, and so that derivative of R with respect to R2 at that particular point, remember we're finding the derivative at a point, the point where R1 is 30, R2 is 45, and R3 is 90, is 15 over 45 squared, which is 1/3 squared, which is 1/9.